In our lesson today, we're going to use our knowledge about scale drawings to investigate the difference between a scale factor and a scale ratio. In the first example, it says that a sharpened pencil is 7.5 inches long. A scale drawing of the pencil is shown. Question A wants to know, is the scale drawing proportional to the actual pencil, and how do you know? Okay, well, by definition, if they're calling it a scale drawing, it must be proportional to the actual pencil. All scale drawings are proportional to the actual object. So yes, the scale drawing, the scale drawing is proportional to the actual drawing. Okay. Again, all scale drawings have to be proportional to the actual or original object. So in this case, the scale drawing of the pencil must be proportional to the actual pencil. Question B says, make a prediction about the scale factor of the scale drawing and then calculate the scale factor. Okay, well, the sharpened pencil, they tell us, is 7.5 inches long. The scale drawing is shown right here, and I can see the length is 1 7/8 inches. Okay, so if the actual pencil is 7.5 inches long and the scale is 1 7/8 inches long, the scale is smaller than the original, which means that this must be a reduction. Okay, this is a reduction. So when it says to make a prediction about the scale factor, all right, well, the scale factor represented by k, if it's a reduction, must be less than 1. Our scale factor must be less than 1. Remember, to calculate k, the scale factor, you have to do the scale length over the actual length. And in this case, the scale length is 1 7/8 inches, and the actual length is 7.5 inches. We have to figure out what that is going to be equal to. So we have to do 1 7/8 divided by 7.5. I'm going to start by rewriting these as single fractions. 1 7/8 is equal to 15/8. And I'm going to divide that by 7.5, which is equal to 15/2. Okay, well, instead of doing this division, I'm going to multiply by the reciprocal. I'm going to do 15/8 times 2/15. And now before I multiply, I'm going to simplify. The 15 simplify the ones. 2 goes into 8 4 times, and 2 goes into itself once. So now when I multiply, I end up with 1/4. Okay, so this complex fraction is equal to 1/4. So this is our scale factor. K equals 1/4. That is the scale factor for this scale drawing of the pencil. Question C asks, what does the scale factor tell you about the size of the scale drawing compared to the size of the actual pencil? Well, if the scale factor is 1/4, this means that the scale drawing is 1/4 the size, 1/4 the size of the actual pencil. Okay, the scale factor always tells you about the relationship between the scale drawing and the original object. In this case, the scale drawing is 1/4 the size of the actual pencil. In example number 2, we see a picture of some tennis courts. And they tell us that the photo below of the tennis courts has a scale ratio of 1 inch to 20 feet. That's a scale ratio. All right. So the question says in question A, does it make sense that this photo is 1/20th the size of the actual tennis courts? Okay, 1/20th meaning the scale factor is 1/20th. Well, back up here again, this isn't called a scale factor, it's called a scale ratio, where it says that 1 inch corresponds to 20 feet. The scale ratio is not the same as the scale factor. Okay, so does it make sense that this photo is 1/20th the size of the actual tennis courts? Well, no, that doesn't make sense. Okay, this would mean that we would need 20 of these photos to recreate the length of the tennis courts shown here. If we had 20 photos end to end, it would not be the length. It would not be the length of the tennis courts. Okay. If I took 20 of these pictures and laid them end to end, I don't even think that would be as wide as a classroom. Okay. And looking at this picture, I see four different tennis courts here. So if I had 20 pictures laid end to end, it wouldn't even come close to the length of these tennis courts shown in the picture. So no, it doesn't make sense that this photo is 1/20th the size of the actual tennis courts. So in this example, again, they gave us a scale ratio where it said that 1 inch was corresponding to 20 feet. This again is called a scale ratio. Scale drawings often have scales with different units. These are called scale ratios. When the units are different, in this case, we have inches and feet, we call that a scale ratio. Since the units are different, the scale ratio does not tell us how the size of the scale drawing compares to the size of the actual object. In order to make that comparison, we need to change the scale ratio into a scale factor. Okay, we need to change the scale ratio into a scale factor by making the units the same. When we make the units the same, then we can change it into a scale factor. So question B says to calculate the scale factor for the picture of the tennis courts. Well, again, the scale ratio said that 1 inch corresponded to 20 feet in actual distance. We need to change this into a different ratio where the units are the same. Okay, so what we're going to do, we're going to take the larger unit, which is the feet, and convert it into the smaller unit, which is the inches. We need to know the relationship between the number of inches in a foot. Well, fortunately, we know that 1 foot is equal to 12 inches. 1 foot is 12 inches. Our scale ratio used 20 feet, so we have to figure out how many inches are in 20 feet. Well, to go from 1 foot to 20 feet, we simply multiplied by 20. So we'll do the same thing to our number of inches, multiply by 20. 12 inches times 20 is going to give us 240 inches. Okay, so instead of saying that 1 inch corresponds to 20 feet for my picture, I can say that 1 inch on the picture corresponds to 240 inches in actual distance. Now that the units are the same, I can use this as my scale factor when I remove the units. K, the scale factor, is going to equal 1 over 240. This is the scale factor for the picture. Okay, remove the units, and then that becomes your scale factor. K equals 1 240th. Question C, the follow-up says, okay, well, if that's the scale factor, what does the scale factor of the picture of the tennis courts tell you about the size of the photo compared to the size of the actual tennis courts? This means that the photo is 1 240th the size. 1 240th the size of the actual tennis courts. Okay, so to review, I can't use the scale ratio to compare the scale drawing to the actual object. I have to first change that into a scale factor by changing the units so that they're the same, and that helps me come up with that scale factor. In this case, the photo is 1 240th the size of the actual tennis courts. In example 3, they tell us that on a map of Coda Middle School, the scale reads 1 centimeter corresponds to 5 meters. A asks, is this a scale ratio or a scale factor, and why? Well, if we look, first of all, we see units and we see that they're different units, so it must be a scale ratio. This is a scale ratio because the units are different. When the units are different, we call it a scale ratio. Also, a scale factor doesn't have units at all. Part B says write the scale ratio as a scale factor. So right now it says that 1 centimeter corresponds to 5 meters. we need to rewrite this so that the units are the same. So again, I'm going to take the larger unit and write it in terms of the smaller unit. I need to know the relationship between meters and centimeters. I know that 1 meter is equal to 100 centimeters. 1 meter is 100 centimeters. They want us to convert 5 meters into centimeters. To go from 1 meter to 5 meters, we multiply by 5. So we'll do the same thing to our centimeters. 100 centimeters times 5 is 500 centimeters. So 1 centimeter corresponding to 5 meters is the same as saying 1 centimeter corresponding to 500 centimeters. And now that the units are the same, I can write my scale factor. K equals 1 over 500. Just take the numbers, and now we can make our scale factor. How does the size of the map compare to the actual size of the middle school? Well, this means that the map is 1/500th the size of the middle school. The map is 1/500th the size of the middle school. In example 4 says an architect drew a blueprint for a new building that she is designing. The scale ratio of the blueprint says that 3 inches corresponds to 10 feet. Find the scale factor. Okay, so in this example, right now we know that 3 inches corresponds to 10 feet. That's our scale ratio. We need to figure out the scale factor, so I have to rewrite this so that the units are the same. I'm going to take the larger unit feet and write it in terms of inches. I know that 1 foot is the same as 12 inches. To convert 10 feet into inches, I took my 1 foot and multiplied it by 10. So I'm going to take the 12 inches and multiply it by 10, which is going to give me 120 inches. Okay, so this is the same as saying that 3 inches corresponds to 120 inches. Okay, well, notice your numbers here, 3 and 120, you can actually simplify that. All right, 3 goes into itself once, 3 goes into 120 40 times. So this is the same as saying that 1 inch corresponds to 40 inches in actual distance. And now this would be what I use to get my scale factor. K equals 1/40th is the scale factor. What does this mean? Well, that means that the blueprint is 1/40th the size of the actual building. Okay, the blueprint is 1/40th the size of the actual building. So once again, we took our scale ratio, we made it so that the units were the same, inches and inches. But then I noticed with my numbers, 3 and 120, I can simplify that. So this became 1 inch. Every inch corresponds to 40 inches in actual distance. And this is what I use to make my scale factor of 1/40th. In example 5, they say that a map of New York State has a scale ratio of 1 inch corresponding to 25 miles in actual distance. So every inch on the map is 25 miles in real life. Find the scale factor. So again, they've provided us with a scale ratio. We're going to change that into a scale factor. Right now it says 1 inch corresponds to 25 miles. We have to write this again so that the units are the same. So I have to take my larger unit of miles and convert that into inches. Now, off the top of my head, I don't know how many inches there are in a mile, but I'm going to do this in a series of changes. I'm first going to change my miles into feet, okay, because I know how many feet are in a mile and I know how many inches are in a foot. So let's first change our miles into feet. I know that 1 mile is equal to 5,280 feet. Okay, that's the conversion from miles to feet. 1 mile is 5,280 feet. we're going to convert 25 miles into feet. To go from 1 mile to 25 miles, you multiply by 25. So we'll do the same thing to the number of feet. 5,280 times 25 means that 25 miles equals 132,000 feet. Okay, 25 miles is now 132,000 feet. Okay, so this is the same as saying that 1 inch corresponds to 132,000 feet. But once again, I need to change this so that the units are the same. They're not the same yet. So now I need to take my feet and change them into inches. I know that 1 foot is equal to 12 inches. So now I'm going to convert 132,000 feet into inches. All right, to scale, this time I had to multiply by 132,000. So that's what I'm going to multiply the 12 inches by, times 132,000. 12 times 132,000 is 1,584,000. That's how many inches are in 132,000 feet, which means that's how many inches are in 25 miles. Okay, so I'm going to write this now as 1 inch corresponding to 1,584,000 inches. And now that the units are the same, this is what I'm going to use to create my scale factor. K equals 1 over 1,584,000. That is the scale factor of our map.